Well, good morning. How's the sound? Is the sound all right? Everybody in the back here okay? Yeah, good. How do I get these slides turned? Just say, turn the slide. Turn the slide. Works. All right, this is Friday, and you'll see that about every hour and a half we have breaks. If you really need to take a break somewhere in the middle of that, we'll just get up and go. It's all right. And come back. We'll all just do fine. So don't feel like you have to sit here and strain if you need to go. We're going to have an early lunch break. That will get us ahead of the crowd, so we won't have to spend a lot of time waiting in line, so we can get back promptly. And toward the end of the day, we're going to do some meditation and experiential exercises. That'll be a little bit of healing, how to use your mind to heal, and some remote viewing. And in the beginning, we'll talk a little about meditation, and I'll give you at least 4 different ways to meditate. And we're going to practice each one of the 4 for just a very short period of time, just so you get a little sense of what it's like. And with a little luck, if I don't talk on and on too much, we'll have time for questions at the end. But in any case, when we get to Sunday, we'll have lots of time for questions. On Sunday, we will have probably 3 hours or more for questions. So if we don't get the questions in between time, just write them down, hang on to them, and we'll have lots of time on Sunday afternoon. There's no hard stop here on Sunday. But I think we'll have time for about an hour or so worth of questions. It's a little hard to tell about timing when you have a 4-day lecture, exactly what the timing is and how long it takes to do what, and that's hard to tell. So we'll just make it up as we go. Move this chair back a little. Okay. I'm going to talk a lot about theory today. A lot more detail on the theory, the physics, consciousness, virtual reality connection, and how the paranormal turns out to be just normal, and the experience. The reason I do those experiential exercises is you'll hear me throughout say, don't believe what I say, consider it with an open mind, and be skeptical, and it's not your truth until it's your experience. Well, if I don't give you some way to gain that experience, then I kind of leave you hanging. That's what the experiential exercises are for, so that you'll have some idea of how to go about getting this experience of the larger consciousness system yourself. Okay. Next slide. Again, the slides are wordy. They're there mainly so you will have a record of it when it's done. You will find them here at my website. And that'll be after I get back and figure out how to put them up there. My website is new and I'm not too good with it yet, but I'll get them up there in probably a few days after I get back, which will be, I think, June 6th, 5th or 6th. So sometime after that, give me a couple of days and I'll have them up there if you want to look at them. And then in a few months after that, 3 or 4 months, you'll be able to see this whole lecture again on YouTube. All of this will be on YouTube. So if any of you don't want to be on YouTube, then be aware of not being where the camera can see you as we do the questions, or pass your question in on paper or something else. Sometimes people want to maintain a low profile. If you want more information, this is the YouTube address. There are about 120, 125 videos there. All my lectures, all my workshops, interviews, all end up on YouTube for free. The books here, that's all three in one, that's a fat book. They are free on Google Books. Let's see. So how many of you were not in attendance last night? How many people we have here that didn't hear what was said last night? Just 2, 3. Okay. Well, I will keep the introduction short then. All right. So how many of you have seen at least one of my YouTube videos? Almost everybody. All right, that's going to make it easy. How many have seen more than one? Well, not the same number. How many of you would describe yourself as dominantly left-brained? That is, you work on logical process. Not as many. That's like techies, you know, scientists, engineers, lawyers, doctors, accountants, mechanics, builders, architects, businessmen, all those people I'd say are left-brained. They deal with logical process. Well, then how many would call yourselves right-brained? That's intuitive. And there's a fair number that don't really know in between. Okay, so there seems to be at least as many, if not more, intuitives than logical process people. That makes a difference. How many of you have ever had an out-of-body or heal with your minds? Okay. How many of you have not had either of those but would like to? Okay, more. All right, this is a pretty well prepared group then. Okay, I can go quickly, next slide, over the background. So I will do this quickly. I'm a physicist, not an academic physicist, but an applied physicist. Next slide. Good, next one. Yeah. Okay. I did my thesis work in experimental nuclear. Never actually worked in that. Went to work in government, making mathematical models of equipment, mostly radar systems, that sort of thing. The idea was to reverse engineer these things to see how they could be confused and beaten. That was the job. Went to work in national missile defense. Done a lot of things. Mostly it turned out to be making mathematical models of things, because that's what physicists are good at. We model reality, so we can model equipment and systems as well as reality. Ended up at NASA as a consultant and worked there for just a couple of years. Consultants just work for short times and then go to the next job. It's more fun that way. They pay you more. So that's about it. So I am a deep dish physicist, science type. If you want to know more about these, you can go 2 places. One, to the free books on Google, and the first section of the books is basically about my background. Or you can go to the YouTube and look for the TMI 22nd Professional Seminar, and that's when I gave a talk at the Monroe Institute for their professional seminar, and I did a little walk through memory lane of the good old days with Bob Monroe. So there's a lot of history there too. So if you want more of that, that's where you can find that. Okay, next. Well, I spent just about the same amount of years as a physicist as I spent researching consciousness. My careers in both started at just about the same time. Soon after my first job out of graduate school, I met Bob Monroe. myself and a friend of mine, Dennis Menerick, we both worked at the same place in technical intelligence. He was an electrical engineer. And Bob had a lab to study consciousness. He just built it. He really didn't know what he was going to do with it after he built it, but he knew he had to build it, so he did. And then I showed up, and Dennis showed up, and we made a deal. He said, Bob, you teach us about out-of-body, and we'll be your scientists. We'll make equipment, and we will do experiments and try to make science out of this experience you had of out-of-body. And Dennis and I both were very skeptical. You know, on the side, we're saying, if this doesn't work out, you know, we're out of here, right? If this guy's nuts, you know, we're not going to stay. So we kind of had that very skeptical approach that scientists and engineers always do have. And it was like, they're going to have to prove this one to me, you know. So, but meanwhile, we're open-minded. We wanted to learn and see if there was something there that we could do. So we had no idea what we were getting ourselves in for. And I had no idea that at that point my life was going to go off in two separate directions, because I would spend the rest of my life researching consciousness as well as working as a physicist. The good thing about the time I spent with Monroe, well, there are many good things about it, but one of the good things about it was that Dennis and I very quickly, a year, maybe a year and a half, learned how to go out of body whenever we wanted to, on demand. That means we learned how to access the larger consciousness system. And we were kind of free in that system. Once you're there and understand it some, then it's yours to explore. There's no real limitation other than the time you put into it. So I was able to do experiments there. I was able to go and do some sort of thing, whether it was healing or whether it was accessing data from databases or having conversations with other non-physical entities or whatever it was. I could do it and I could repeat it. And then I could change a variable and repeat it again. And I could do that 100 times because it was something I could do, the same way as anytime I wanted. That gave me an advantage of being able to do experiments and to do science in the larger consciousness system, which gave me an inside view of how things work. Had I not had that, had I had to figure out how this whole thing worked from the outside, looking in at a mystery, I would never have gotten to base one. So that's the thing that made all the difference in the world. Once you are aware of that larger consciousness system, then you can you have the ability to do science there, to experiment. And I did. And my mission with Bob was to figure out how things work and why they work that way and what were the limitations and what could you do with this thing called consciousness and what couldn't you do with it, and why didn't experiments with people not always repeat? Why were they sometimes work and sometimes they didn't work? What was going on? So that was my mission, and I did that even after I left interacting with Bob. I continued that for the next 35 years. And 35 years later, I go, I think I know enough about this to explain it to somebody else. Well, I tried to explain it to somebody else, and their eyes rolled up in their head, and they gave me that funny look like, are you kidding? So I thought, I need to write it down. Because when you write things down, it forces discipline on your thoughts. Your thoughts have to be coherent if you write them down. Whereas if you're just speaking, they're kind of fuzzy and you're not being this clear. So when I wrote it down, I ended up with 8.5 pages. And I was done. And I passed it to people and I got the same reaction. Eyes would roll up in their head and they'd kind of look at me strangely. And I'd say, well, what is it you don't understand? And they didn't know where to start. So I enlarged it. I took their questions and I added some to answer those questions. And I'd pass it out again and people would ask questions. So I'd answer their questions and I'd pass it out again and ask more questions. And eventually I ended up with so much material that it wasn't one book, it was 3 books. So I had a lot of help writing this book because people kept asking me questions. That's why when you read the book, sometimes it sounds like this book is anticipating and answering your questions, because that's the way it was made. It was made to answer your questions as I went. And that's why it got so fat, because I had lots of different people reading it, and they all didn't have the same questions when they read the same section. So different people approach it with different perspectives and different knowledge sets. And that's also why sometimes it sounds a little redundant, because I'll approach the same concept 3 or 4 different ways, because I had 3 or 4 different people reading it, and they all had 3 or 4 different questions, you see. And if you happen to be one of those that gets them all right away, you might find it a little redundant that you have to get this from all the directions. But my point was to make this book accessible to everyone, an on-ramp that everyone could read. All right. We will turn the slide. So first, I'm going to explain a little bit about what my big toe is all about, so you have some deeper concept of the context here. Okay, the idea was to explain consciousness. How does consciousness work? Again, what can it do? What are its limitations? What's the system? What are these databases? Now, I call them databases, but if you look at Hindu theology, you'll see they're called the Akashic records, and other disciplines call it other things. But there is just information available in this reality if you know how to access it. So my job was to find out how it worked and explain consciousness. Then a funny thing happened on the way of doing that is that I realized after it was written that it also explained physics. I didn't expect that. I knew that one overarching understanding would one day explain everything, but I didn't know that I was writing it until I really was done, took a look at it, and said, wow, these same ideas explain the double slit experiment. They explain why speed of light's constant. They explain how tunneling works in modern physics. They explain a lot of science. Matter of fact, they explain all the things that aren't known. They explain the questions of what is mass, what is time, those sorts of things. What is charge? And why, how can the universe be expanding? Into what? They explain all those things. So then, at that time, I realized that I had that overall arching thing that did indeed explain everything. And then I started looking for things that it didn't explain, to see if my model couldn't enlarge or grow or modify or something. And I've done that over the last decade or so. And I've added things to the model and fleshed out some of my explanations. And I'm sure there's lots of more logical consequences of this model that nobody has fleshed out yet. That will happen later. Well, it ended up being this overarching thing that unifies physics with metaphysics. The objective with the subjective. It does them both. And how is that? People understand. Well, I understand how science explains the objective, but how does it explain the subjective? It explains the subjective because it explains the subjective experiences that you have. And why do you have that experience? What is it connected to? Why did you, experience those things, whether it's an intuitive thing or some other personal thing? Love is a subjective experience, so are a lot of other important things. So it does explain subjective states as well as objective states. The paranormal becomes normal. Well, not necessarily all of what was called paranormal, but most of it that had any good scientific research to verify its existence. It just becomes normal. It's not para. Para kind of means beyond normal. It's just normal. Changes philosophy and theology. So all of these hard problems, which are, there's lots of hard problems in philosophy and theology, like why are we here? What is the point of life? What happens after death? There's lots of those kinds of questions, and it explains those, as well as why speed of light's constant. So that was very encouraging. I'm likely to break some of your favorite paradigms. I'm liable to run over some of your most cherished cultural and personal beliefs and scientific beliefs, but just remain skeptical and remain open-minded. Now, if your motivation for being here is to decide whether or not you should believe what I say, you're approaching the problem incorrectly. Such an approach will guarantee frustration and little personal progress and understanding. That's because you will almost never have enough data to prove anything important. Think about that. You can almost not prove anything important. Can any of you prove who your parents were? Well, that's obvious, right? Sure you can. Well, can you? Do you know that as an infant you weren't switched with another infant by accident or on purpose? How can you prove that that didn't happen? You can't, you see? You can't prove even the most obvious thing. And if you think about your life and everything in it, you can't prove anything. We accept things with uncertainty. There's some uncertainty whether or not our parents were really our parents. Well, maybe we sort of look like them. That's good, but that's not proof. A lot of people from different parents might sort of look like them. Okay? So proof is an almost impossible thing. In science, we don't try to prove things. We look for evidence, you see. So there's evidence that they were your parents because they brought you home from the hospital and, you look like them and so on and so on. But there's no proof. So proof, Dean Radin has a phrase he says, and that's proof is for whiskey. Evidence is for science. Science always has some uncertainty about what it's saying. There's always uncertainty with it. So you look for evidence, not proof. Now, if you're looking for me to give you objective physical proof of the non-physical, you're wasting your time. Can I help you experience psi phenomena for yourself so you can come to your own conclusions? Yes, certainly, I can do that. Can I teach you how to affect physical things with your mind? Sure, that's not hard. Can you absolutely, objectively, and conclusively prove the reality of these experiences to yourself? Sure, not a problem. Will your experience serve as proof for anyone else? No, never. Everyone must experience this for themselves. Your experience will prove nothing to anyone else. Now, your experience may be evidence for someone else if they trust you and think you're a solid, intelligent, sane person. It might be evidence for them, but it's not proof. Okay. If you don't gather your own data and learn your own lessons, all you're left with is belief. See, if it's not your experience, it's not your truth. If it's not your experience, it's just your belief. That's why believing what I tell you is not the goal here. It's not what I'm trying to do, is to convince you to believe what I say is right. I want to convince you to go find out, to go have your own experience, and to be open-minded enough to consider it while you collect your own data. Okay. We tend to jump to beliefs very quickly. If there's something we don't know and we think it's very important, it's maybe even critical to us that we understand and know it, but we just don't have the information. We don't know it. There's a fear there of the unknown. I don't know this. I need to know this. What am I going to do? Well, a belief solves the problem. You just believe, pick an answer, believe it, and then you're done. You don't have to worry about it anymore because now you are complete. You know the answer. It's a belief. So belief is mainly generated out of the fear of the unknown and the fear of not knowing. And that's a fear that most of us have. Okay, change the slide. Okay, we're going to talk mostly in the beginning about philosophy of science, a little context of what science really is. Then we'll talk about science, and then we're going to talk about consciousness and science. But theory is mostly talking about the facts. Now, many of you put up your hands when you said you were intuitive and right-brained. And I know right-brained people really don't have a strong connection with the facts. They don't need the facts. They intuit the truth. Facts just get in the way. They just muddle everything up. They confuse you, and it is unnecessary. It's like, why go through all these steps when I can just go to the answer? Well, there's an advantage to knowing the theory. There's an advantage to knowing those steps. If you really understand it, then it's much, much easier to if you understand the theory, it's much easier to understand your experience, why things are the way they are. The things that you get. Why is it like that? What does it mean? If it's just intuition, you have a vague idea of those things, but you're never quite sure of the context. The context is always floating around, but if you're right brain, then you really don't mind, because context isn't a big thing either. So I'm going to do a lot of theory, and you right brain people are just going to have to tough it out, because I'm a scientist and that's what I do. So we'll try not to be too hard on you. But toward the end of the day, we'll do that experiential things, and then you'll be in your element. All right, little picture. Talking about little picture and big picture science and models. Now, my work is called My Big Toe, and toe means theory of everything. So yesterday I talked about big toes and little toes. A little toe being basically a bridge between quantum mechanics and relativity. I think we lost sound. It's back. Okay. And a big toe is that plus everything else, plus consciousness and the subjective and paranormal and all the rest of it. Okay, little picture physics describes how things work, not why things are. Okay, little picture hard science has no interest really in the subjective at all. The subjective is something it can't control because it's controlled individually, therefore it doesn't want to have anything to do with it because it can't control it. But that means things like meaning, significance, point and purpose, relationship, morality, value, justice, beauty, love, caring, compassion, fear. These are subjective and fall into the realm of philosophy and metaphysics. But these are also the things that give your life meaning. These are the things that makes life worth living, make it fun, that make that give you the substance in this life that's significant. So we have science that wants to study all the things that are things, basically the set, if you will, the stuff. And all the really important stuff, which is the feelings and the caring and the love, and even the fear and all that stuff that pushes you this way and that way and pulls at you, all of that is left out of science. So the idea that science explains the world, it just explains this little world over here of the stuff. All the rest of the world, which is a much bigger part of the world, it has nothing to do with. So we're looking really for a bigger picture here. Okay. To be valuable, big picture science must provide a superset. That is, it must provide better, more complete physics and better, more complete metaphysics. Okay. Science measures only effects. Only effects. So we think of all the particles. Science says that the world is made of little particles. We start with subatomic particles, which make atomic particles like atoms, which make molecules, which makes us and the stuff. So it's this ground up, building up out of little particles. But yet, nobody's ever seen any of these little particles. All these particles are hypothetical, unseen, because we can't measure, we can't see, we can't directly interact with these particles. But what we can measure and see are the effects of the particles. Okay? We can see the effect when when an electron hits a conductor, we can see a current. When an electron is in a magnetic field, we can see that it goes through that magnetic field and it bends its trajectory because it has charge, and charge gets bent, and charge has forces. If it moves through a magnetic field, it will make the charge go one way or another. Okay, so that's what we see. We see effects. And when we see effects, then the scientist makes up a model. All of physics, all of science is about models. It's not about facts so much as it is about models. The facts are the effects. Why that effect's like that, what the causality is to get that effect, that's all just hypothetical. So all these particles are just hypothetical models. And we start with, I talked about the electron last time, so we'll talk about the proton this time. Rutherford sort of discovered, or at least he was the one that led to the discovery of the proton. Early on, we didn't understand much of the structure of an atom. And Lord Rutherford sent positive particles. This was kind of the first particle experiments, if you like. This is probably 1800s. Accelerated some positive particles into material and found that the particles were all scattered. In other words, here's the material and here's the proton, and it comes in and it would get to the material and curve. It would go that way, or it would go this way, or it would go this way. It was pushed away. And he knew he had positive particles that he was accelerating, so he said the atoms in the material must be made of particles that are positive. And that's when somebody said, let's call that a nucleus. And it has protons in it. See, that's where that came from. And the protons are positive. So these little positive things come in and they get close to these other positive things, and like charges repel, just like magnetic fields. Like charges repel, opposite charges attract. So you have positive coming at positive, it repelled, and that's what happened. So he saw the effect, the fact that these protons were bent, their trajectories. That was what he measured. That's the effect. The proton was a model. So that's the way all of our physics is done. Models. That's the way my big toe is done. My big toe is a model as well. It's just a model. Okay. The problem there is that physicists, particularly physicists, and the rest of the world as well, because they believe the physicists, is that they believe that the model is actually a fact and not just a model. So they make up a model, and when they first make up the model, they know they just made it up, and that is hypothetical. But 4 or 5 decades later, that model is seen as a fact. That's the way it is. So when scientists, some 60 or 70 years later, find out that electrons and protons are not little chunks of mass with charge, they find out their probability distributions, and everybody's upset because they knew they were little chunks of mass, with charge, but that doesn't work. That doesn't explain the experiments anymore. And nobody wants to let go because they know it's a little chunk of mass with charge, you see. So then there's an existential problem of how do we explain this? How do we deal with this fact? So the model turned out to be wrong. And that is a situation that happens a lot, that the model turns out to be wrong. There's another one we could talk about, and that's gravity. So we have gravity, and we can do an experiment that shows us that gravity exists, right? We can drop a rock and it goes down. It doesn't stay there and float, and it doesn't go up, it goes down. So we say, oh, that's gravity. Okay, that's an effect. Gravity indeed does exist. And then we say, well, my model is that masses attract each other. So every mass attracts every other mass. And that's why, and this Earth is a great big mass, so it attracts this little mass, and that's why it goes down, because masses attract each other. Well, Newton gave us that model, and that model was fine, and actually for many decades, that model was a fact. Masses attract each other. If you took science in school, that's what you were told. And then comes along Albert Einstein and general relativity, and he says masses don't attract each other. It's curved space-time. That's why space-time has curves. And these particles follow the contours and curves of space-time. It's all geometry. It has nothing to do with mass attracting mass. Whoops. You see, now we look at Einstein's model, and his model gave the same results, but was a little more general. It gave additional results as well. So then we like that better, because it answered more of the questions. You see, that's another case. And this is a common thing in physics, where we believe our models are facts. We put them in textbooks as facts. We teach everyone they're facts when they're just hypothetical models. Okay. Am I doing better, translators? Good. They got me last night for talking too fast, so I'm trying to speak very slowly today so they can keep up. All right, let's see. Okay, today I'm going to explain big picture science, and I will show that big picture science derives little picture science as well as metaphysics. Okay, now, little picture science holds the opinion that there is no larger causality, no more fundamental structure that supports and defines physical reality. In other words, this physical universe is all there is, period. If it's real, then it has a cause in this physical universe. Physical reality just is. Okay, it starts from a big bang out of nothing. Well, there's no scientific justification or even much speculation, no credible theory that's such an assertion that our universe just starts from nothing. Well, I shouldn't say from nothing. It starts from a ball of plasma. But the ball of plasma can't be part of our universe because our universe hasn't started yet. Not until the ball of plasma goes bang and is led to expand. Well, what was holding it there in the first place? What kept all that pressure and temperature in that little ball? Why was that little ball sitting there not expanding? Where did it come from? How did it get there? It didn't come out of our universe because our universe couldn't create it. So it starts with an assumption, a mystical assumption. If you told a scientist that you believed in things that sometimes happen without physical causes, they just happen, they'd call you a mystic or a pseudoscientist or a fool. But yet they have the same assumptions at the basis of their science. Okay. They also have a lot of hard problems that they can't solve, like what's mass, what's charge, what's time, what's space, what's spin, what's gravity, and they can't find any causal chain to explain any of those things. These things just are. Again, things popping out of nothing. They just are. Where does charge come from? Where does mass come from? They don't know. And it seems impossible to find out because there's nothing that causes mass. There's nothing that causes charge. We just have it. So again, physicists start with this is all the basic stuff of physics, right? What physics is based on is space, which is Big Bang, ball of plasma, mass, charge, spin, all these things make up physics. So all of physics is basically based on, it just is. Don't ask me. Don't ask me these questions, it just is. Trust me. That's the way the world is, which is completely non-scientific. They wouldn't accept anything else as just is if it had no causality. Okay. Turns out that things just being as they are is a hallmark. I don't know how that translates in French, but it's a sign of being. Do I do that? It's up here. I don't know. We get that every day. Yeah. That's it. That's it. Okay. I'll try not to do that anymore. It's a sign. These things that just are, that pop out of nothing, that have no causal explanation, that's a sign of a virtual reality. Virtual realities have to be that way, because a virtual reality is not at all until the computer starts to run and compute it, and then it suddenly is. You see, there's no causality there as far as that reality is concerned. So if you are a Sims character or a World of Warcraft character, those are virtual reality games, and you search for your origin, you won't find an origin, you'll find a starting place. It just started. You go back to the beginning, back through all the history of your virtual reality. So the elf goes to the first elf, the first barbarian, the first rock, the first tree that was ever seen in that reality, and try to go any further back than that, and there's nothing. And then suddenly, it's there. That's the nature of virtual reality. And the fact that we have mass and time and space and so on, those are just parts of the rule set. Every virtual reality is defined by a rule set. That's what makes a virtual reality. It's the rules that calculate it. If it's a simulation, it's the rules, the algorithms, the rules that create the simulation. So you make a virtual reality by having information and constraining that information with a rule set. Creates a reality. Okay, so all these problems the physicists have are really indicative that this reality is a virtual reality. Okay. Okay, and an interesting thing about physical and non-physical is that neither one is fundamental. Okay, we talk about the elf finds out that his reality has to be computed in a non-physical space. We talked about this yesterday. Everybody was here yesterday, so I'm going to skip a couple of steps. We find out that the virtual reality is computed somewhere else other than the virtual reality, because a simulation can't compute itself. Okay? That means it's non-physical. The consciousness that's playing the character in the virtual reality also has to be non-physical, because the character, being a virtual character, is played by a player who is the virtual character's consciousness, and that consciousness has to talk to the computer that's creating the virtual reality. That's how virtual realities work. The computer and the player send data back and forth. The virtual reality is just data on a hard drive. Nothing there that's alive. It's just data on a hard drive that's virtual. So we have a non-physical player consciousness and a non-physical computer computing it. And we think about this physical, non-physical, and realize that there's nothing fundamental about it. You can think that everything's physical or everything's non-physical, because what's physical is just a function of the observer's perspective. So if you're an elf, the world of Warcraft is physical. You bump into rocks, you run into trees, you have to open doors, you can't walk through them, it's physical inside that virtual reality. Then you leave that virtual reality and go out to where the consciousness is, and out to where the computer is in the non-physical. And if you're in that non-physical, like we are when we play World of Warcraft, it's physical to us, although it's non-physical to the elf. And then you leave our reality and go into the larger conscious system, and that's non-physical. But when you're there, it's physical, you see? And this reality, this virtual reality, seems non-physical. So physical and non-physical are really without much meaning. They're relative to the perspective of the observer. That's really the next step up in relativity theory. We have in relativity theory that there is no fundamental inertial plane. All inertial planes are relative to each other. And that's basis for the theory of relativity. And here we have the next step, which says all reality frames are just relative to the observer, just like the inertial frames. Okay, so so we talk about the non-physical. It's not like, wow, non-physical, that's a scary place. That's it's just a perspective. When you're in that non-physical, it's as physical as this is. And this isn't physical at all. It's just a way of looking at it and a way of talking, because we're all used to being in this physical reality. I'll talk about the non-physical and you'll know what I mean. I mean, not here. Okay, next slide.